All right, this is pre-algebra lesson 1.7, right? Inductive reasoning. Big old fancy words, right? Inductive reasoning. Let's read about it. Let's look at the top of page 35. See what inductive reasoning means. Somebody read that for me. Brad, read that for me. Inductive reasoning.
Is making conclusions based on patterns you observe. A conclusion you reach by inductive reasoning is a conjecture.
Good. Inductive reasoning is making conclusions based on patterns you observe. A conclusion you reach by inductive reasoning is a conjecture. This is how simple this actually is. Okay, I'm going to watch. I want you to watch. I'm going to show you a pattern. What is next? What would the next thing be? Draw on your paper somewhere what you think would be the next drawing. What would be the next symbol? What do you think? Well, the first one, the arrow's up, then it goes over there at a 45-degree angle, then it goes to the right, then it goes at, what's the next one? What's the next one? Straight down, right? How many of you have that, an arrow straight down? No? But do you see how it's going a quarter turn, a little eighth of a turn each time? You see that? What if I have, I don't know. They have one that looks like this. They have one. What's next? What would the next one look like? Draw something with it you think the next one would look like. You have to follow the pattern. You're looking for a pattern here. Shh. So what you do is you look for a pattern, you observe this, and you go, okay, they're all circles, and inside's a triangle on the first one, then there's like this rectangle thing, and then there's a, what's the pattern here? What would you say is weird? What would you say is weird about each one of these that we could use to make a pattern? What do you think, Amy? Yeah, there's 3 sides in that one, 4 in this one, 5 in this one. Oh, that means this one's going to be a, what's that called? Hexagon, right? Hex means 6, so it would be like 1, 2, 3, 4, 5, 6, right? That's what it would look like. Make sense? Sometimes there are patterns that are numbers, and you've been doing this again for a long time. What if I have this? 2, 5, 8. What's the next one? What would the next one be? See, I know a lot of you will be able to do this, but there's some tricky rules about this. Kyla, what's the next one? 11. So here's what you do. Let me tell you how you do this, okay? What you do is you have to write a rule. You have to come up with the rule. How did you come up with 11 anyway? What did you decide? How did you make it? Did you just make that up, or what did you see? So then you just found the pattern, right? You found the rule. Here's the deal. You want to write a rule for this sort of thing. This is how you write a rule for number patterns. Are you paying attention? This is how you write a rule. You would say that this rule is that it starts with blank and blanks repeatedly. Now, this is the basic pattern for writing a rule. Starts with blank and blank repeatedly. Here's what it is. This starts with 2 and adds 3 repeatedly. Does that make sense? And 3 is added repeatedly. So what's the basic template for writing a rule? You write the words starts with blank and blanks repeatedly. Okay? So you guys all got that one. Let's try this one then. Let's do this. Let's go I want you to write a rule for me, and then tell me what goes in the box. Write a rule for me, and then tell me what goes in the circle. What's the next number in the pattern? Lauren, what's the rule?
Starts with 3 and adds the next number.
Nope. You said, let's go through this though. That's good. Let's go through it. You said starts with 3 and adds the next number repeatedly. Let's see if your pattern works. So you go like this. 3 plus 6 is not 12, right? Makes sense? So okay, and then 6 plus 12 isn't 24, and 12. Does that make sense? Or even 9 plus, it doesn't make any sense. So, okay. Somebody else come up with one. Brad, what's the rule?
It starts with 3 and doubles.
Okay, and doubles. Now, here's the deal. You want to use math, or doubles works. What's another way of writing doubles, Gina? Multiplied by 2, right? Doubles repeatedly, multiplied by 2 repeatedly. That's what you want. And let's see if that's true. 3 times 2, is that 6? Is 3 times 2 6? Is 6 times 2 12?
Yes.
Is 12 times 2 24?
Yes.
We have a pattern. So then what's the next number then? 48. 48 is the answer. Does that make sense? Here's something else. This gets a little bit weird. Here's the deal. I'm going to show you this one. I know you guys could figure this out, but here's the deal. Whenever you start with, this is going to be starts with 4, obviously, right? You're going to start with 4 and. What are my two options here? Whenever the number is getting bigger, I have two options. It's either going to be addition or multiplication, right? So, since that's true, we have to decide, okay, first, it could be addition. If it was addition, then what would 4 plus 8 be? Or how would we go from 4 to 8? It would be plus 4. Do you agree?
Mm-hmm. Yeah.
What else could it be? How else could it go from 4 to 8? It could go times 2, right? It could be either plus 4 or times 2. Does that make sense? It could be plus 4 or times 2. Now, now let's go see if that's true. 8 plus 4. Is 8 plus 4 16? No. Is 8 times 2 16?
Yes.
Yes. So we've found our pattern. Does that make sense?
Yes.
It's this. It's times 2. Then you'd say starts with 4 and multiplied by 2 repeatedly. Okay? But you can do that. Now, what if I gave you one like this? This one looks pretty good. Let's see what the... Can you tell me what the rule is? What does it look like? What is the rule?
Starts with... Oh, you want me to just tell
That's
you?
not it. Here we go. Watch. This is what you do. You go for... At first, you're going to go, okay, how could the 3 become a 9? What are my options? Could be a plus 6 or times 3. Agreed? Add 6 or times 3. That's my options. The next one. If it is plus 6, then is 9 plus 6 18? No. So if it is times 3, is 9 times 3 18? No. So then here's the rule for this pattern, is that there is no pattern. Does that make sense? There's no pattern. It has to be consistent. It has to be the same thing across the board. As you go, it has to be the exact same thing. Otherwise, it's not a pattern. Right? Otherwise, it's not a pattern. If I say, what's the pattern of these numbers right here? 1, 8, 42.6, negative 3. I say, okay, what's the pattern there? There's no pattern there. Right? Makes sense? Question, Brett.
What if it was times 2 times 3 times 2 times 3?
Right, there, that is possible. I'm not going to give you those. Okay, I'm not going to give you those. What?
Fibonacci?
Oh right, the Fibonacci sequence thing. Yeah, it's weird. I'm not gonna teach that. Okay. Okay. Sometimes people say something that makes a claim about a rule. Are you listening? Sometimes people in life make a claim about a rule. If it's totally true and the rule works, great. Most of the time in life, people that make claims, there's exceptions to the rule. For example, if I said all birds fly, while that is almost totally true, right? All birds fly. That's not true. There are a few birds that don't. So here's the deal. What I'm looking for you is to come up with a counter example. I could say that all integers are positive. Is that true? Are all integers positive? No. So then give me a counterexample. Give me an example that would disprove my statement. Give me a counterexample. No. What I'm saying is you give me an example. You're actually going to give me something that disproves it. So if I said all integers are positive, and you go, nope, here's my counterexample. Give me a counterexample. -3. That disproves my rule. Does that make sense? That disproves my claim. So if I said all birds fly, you could say, not true, because ostriches don't fly. What else? What's another example? A what? Penguins don't fly. Makes sense? Chickens do fly. Yeah. They do fly. Doesn't matter, but they do fly. Shh. The point is that you want to come up with a counterexample. So if I were to say, if I tossed a coin 4 times and it came up heads every time. Okay, flip a coin 4 times heads. If I flip a coin a 5th time, it will come up heads. What's the counterexample to that? If I said a coin gets flipped 4 times and it comes up heads every time, if I flip it a 5th time, it will come up heads. What's my counterexample, Kyla? Well, you could say, so what could happen? What is my counterexample? You flip a coin and you get tails. Right? Does that make sense? That's a counterexample. All right. What about this? Tell me this. I'm going to give you another pattern, and you tell me what is the next one, okay? It's going to be kind of weird. Okay, I want to know what the next pattern looks like, and I want to know the number. Okay, we're talking about numbers here, okay? I want to know what it looks like. You're going to draw it for me, and you're going to tell me the next number, all right? All I care about is that you draw it for me and tell me the next number. So what's the next number, Sheena? 16. What is this number here? 1. What's this number? This number?
9.
Okay, so if you saw this, this would be a tough one to write a rule for, right? It would be a tough one to write a rule for. But you can see the pattern, right? You can see it. This is 1 by 1. This is 2 by 2. This is 3 by 3. What's the next one?
4 by 4.
What is, okay, so this one is 16. What is the next one then?
5 by 5.
Which would be 25. Do you see it? Okay. What about this? I'll give you another one. You ready? This back? I want to know the number. I want to know the number. Okay, what's this first number here? 1. What's this number?
3.
What's this number?
5.
Okay, so listen, if I was to give this to you and say, there's our pattern, what's the next one? Look at it. So you would say that this one's an easy one to write a rule for. What is it? What is the rule? What's the rule? Starts with 1 and adds 2 repeatedly, right? Because what's the next number? It would look 1, 2, 3, 4, 1, 2, 3. It would be 7. Make sense? How many of you got 7?
I did 7, but I didn't do the rule.
Right. All right. I didn't ask you to. Right. Okay. I think you guys can do this. All right. Let me give you your homework. Today you'll have time to do it. Page 38 to 39, 1 through 20 even.